The mass of all the different pies sold at a market is normally distributed, mean 400, standard deviation 61 gram. It means on average pie is 400 grams. Sometimes you can get maybe 401, sometimes it can be only 400. That is why you have a deviation here, 61 gram. So they say I have to look for a probability where the mass is less than 4 to 5 gram. All the unit is same, gram. I'm going to let the mass to be x, and if you want you can define your distribution first. 400, standard deviation 61 squared. 61 squared because this is a variance here. The parameter is mu and variance, mean and variance. So now the mass, which is the x, must be less than 4 to 5. Change it to z. (61). I think you know how to do after this. Please use your table. How many digit will you take? 4. Why? Because the table only accommodates that. 0 is already 1. 4. It's actually 4098. So since I'm only taking 4 digits, so I'm going to do 410. Read it from the table. (0.41). It is 0.6591. This is pretty basic and the answer makes sense to me. How do I check whether the answer makes sense or not? You go and draw this. The middle part is 400, right? And you know this part is 0.5. Now you are looking for lesser than 4 to 5. If it is less than 4 to 5, the answer has to be slightly more than 50%. Answer is slightly more than 50%. Now part B. 4 randomly selected pies all have masses of less than 4 to 5. What is the difference between the first part of the question and second part of the question? So just now I'm only considering one pie. I only considered one pie and I want the mass to be less than 4 to 5. Now what I'm doing, I'm selecting 4 random pies from maybe n number of pies, and I want all to have mass less than 4 to 5. See, is my subject a mass of one pie now? No, it is already finding probability of number of pies. So the base now is number of pie. Will you be still using normal distribution here? When you are talking about number of pie, it is only whole number. So which distribution works for only whole number? Binomial distribution. I mean, based on your syllabus, you only know normal, binomial, geometric. N is equal to 4 and the R is equals to 4. Probability of getting the success is actually 0.6591. So how do you do this? For choose 4, can you recall the formula? N choose R, P R, 1 minus P, N minus R. 6591 power 4 and then whatever power 0. It's going to be 1, so I am not going to solve that. if you don't want to do it like this, if you think that you just want to do by thinking method, feel free to do it. So how do you do by thinking method? The first pi that I selected, the mass is less than 659. I mean the probability that is less than 425 is 65.91%. Second one is also 65.91%. Same goes to the third and the fourth. And in this scenario, it is a independent situation. So just take the probability and multiply all of it. So what will we end up with? If you calculate, you should be getting 189. Now let's look at part C. This is also another binomial scenario. They said exactly 7 out of 10 randomly selected pi have mass less than 425. So how do you think for this question? You know that you are having 10. Okay, how many? I have 5 here and then another 5. Now they're telling exactly 7 must have mass less than 425. Which 7? Are you saying this 7? It can be any different possible of 7, right? So do you think juggling is necessary? Yeah, what considers the juggling? It's this part here. So 10 choose 7. 7 of them are going to have mass less than 425. So you take this p value, put it here, and then get your q value, power 3.